Bismillahirrahmanirrahim. So dear students, so today in the organic chemistry class, we will be having two important reactions for the preparation of amines. One is Gabriel Phthalimide reaction and Hoffmann Bromamide reaction. Now both these reactions are very important from the examination point of view and also from the competitive examination point of view. So let's start. So your first reaction is Gabriel Phthalimide reaction. Gabriel Phthalimide reaction. So let me take the pointer out. So this basically Gabriel Phthalimide reaction. In this case, we need potassium salt of phthalimide. So this is our, you should say a reactant, or you can say it's a substrate, potassium salt of phthalimide. So this is your potassium salt of phthalimide. This. Now in this reaction, I have shown this is basically, this is the preparation step, this one. From this to this is the preparation step of, this is called a potassium salt of phthalimide. This is called phthalimide. So phthalimide, you can easily remove this H plus with the help of base to form this anion, and then this will be stabilized by this counter ion from the base. So this is your potassium salt of phthalimide. So in this case, you require potassium salt of phthalimide, and that reacts with the alkyl halide. You can see here it reacts with the alkyl halide Ri, Rx, whatever, to yield N-alkyl phthalimide. So this K plus, or you should say, it gets replaced by this R plus. So it forms N-alkyl. It's called N-alkyl phthalimide. N pe R group. So this is N-alkyl phthalimide. Then this N-alkyl phthalimide undergoes hydrolysis to yield mixture of primary amine and phthalic acid. So when you hydrolyze this N-alkyl phthalimide, you can show here on the arrow H plus and water means acidic hydrolysis. So what happens, it gets broken down here, being H here, another H here, and then this forms phthalic acid and you get the primary amine. So Gabriel Phthalimide reaction is used for the preparation of primary amines. This is important. Okay? Now you can take the example, you need not to do anything, just replace the R. Now this is your potassium salt of phthalimide. You can start this reaction from here also. So now what you do, you are taking, instead of R, we are taking ethyl iodide. So this K will get replaced hereby. So we'll have an ethyl group here. Now you will name it N-ethyl phthalimide. Then do the acidic hydrolysis, just break it down. You get phthalic acid and ethyl amine. So our product is this one, ethyl amine. So this is used exclusively for the preparation of primary amines. Now important thing is that this method doesn't works good. It's not possible for the aryl halides. So Gabriel Phthalimide reaction, with the help of this, you can prepare primary amines. It can't be used for the preparation of aryl halides. Okay? So let's move to the next reaction, and this is the most important reaction, particularly from the competitive examination point of view. So a lot of times I have seen the questions coming from this portion. So let's move. Hoffmann bromamide reaction. In this case, acid amides. Now this is your acid amide. It reacts with the bromine in KOH. It reacts with bromine in the presence of base, potassium hydroxide, to give the primary amines. So this reaction also gives us primary amines. But question is that it has one carbon lesser than the primary parent amide. Now this amide, you see, you have how many carbons? This C and then this R group. R group can contain any type of carbons. But the product which is formed, it has less carbon, one carbon less. So this is not there, this portion. And this is released in the form of potassium carbon. This is carbonate plus potassium bromide and water. Now let's take the example. You take acetamide, instead of R will use CH3. So it reacts with bromine and KOH. Remove one carbon, so you'll get methylamine. You can use the same reaction for the aromatic amides, that is your benzamide. So it reacts with Br2 and KOH. Simple, remove this CO in the form of potassium carbonate, so you'll get aniline. Now, so this is important. So Hoffmann bromide reaction is used for the preparation of primary amines. And number one, and number two thing is that the product which is formed, the amine formed, it has one carbon less than the parent amide. That's why this reaction is also called as degradation. Hoffmann degradation. Why? Because it degrades, it removes one carbon. The product formed has one carbon less. That's what it's called as Hoffmann degradation reaction also. Now let's look at the mechanism. This is important. Because here also the question, the examination, in the examinations we have seen the questions. So normally what happens here, this is your amide with the Br2 and KOH. Now KOH is a base, and in place of this bromine, I will show in the shortcut, one of the hydrogen atoms will get replaced by this Br. So there's a mechanism, but I will not show that. You can also do it, remove H from here to form NH negative, and that NH negative will attack the bromine, so the bromine comes here. Okay? Now this is your formed bromine substituted amide. Now in this case, in presence of base, since your base contains potassium hydroxide, your medium contains potassium hydroxide, and this nitrogen is acidic, it contains acidic hydrogen. Why? Because on one side you have electronegative bromine, on other side you have carbonyl on the adjacent. So this is acidic, so hydrogen gets easily replaced. That will be taken by the base to form water, so our compound is this one. This is anion formed. Now this anion, now nitrogen is negative charge, this bromine can easily get removed. So what is formed is this nitrine now. Dekhiye. These two electrons, they are got away with the bromine, so this negative charge get removed in the form of a lone pair. Now this compound is called as nitrine. Remember, this is very important that in the Hoffmann bromamide reaction, intermediate formed is nitrine. Now this was the question asked many times. Now in this nitrine, now it undergoes rearrangement process. You can see this R it comes here. It moves from C to N. It's called a rearrangement to form isocyanate. Such a structure is called as isocyanate. So question was asked from this portion also. The nitrine which is formed in the Hoffmann bromide reaction, it rearranges to form what? Isocyanate. So this is isocyanate. Remember R, N. So isocyanate formula you can remember this way: R, then single bond with N, then double bond with C, and then double bond with oxygen. Now this type of structure we get is called an isocyanate compound. Now this isocyanate, it undergoes hydrolysis or acidic hydrolysis. You can actually add water on this. When you add water, simply what you do, add 2 hydrogens here. I'm just showing it shortcut. Add 2 hydrogens here, so you'll get primary amine, and then obviously remove this carbon in the form of carbon dioxide. So this is the important mechanism, that in the Hoffmann bromide reaction, we have to remember that this reaction is used for the preparation of primary amines. Number 2, in this case, the amide reacts with the bromine in presence of KOH. Then the amine which is formed, it has one carbon less than the parent amide, so it's a degradation process. In its mechanism, the intermediate formed is nitrine that rearranges to form isocyanate. So this is the important some important information which you have to remember. So as usual, you can download this note in the description. There's a link, so you can use it for the exam purpose. So thank you. This is all what we have. Thank you.